A beam of rectangular cross section 150 mm by 200 mm is simply supported over a span of 5 meter. If the shear force at a section in beam is 6 kilonewton, find the shear stress at a distance 20 mm above the neutral axis NA. Right? So this is the numerical that is given. I was just making this diagram. Uh, Let me just quickly complete this. Right. Now what is he given us? This is 150 by 200 mm. So this is 150. This is 200. And you have to find the shear stress at a distance 20 mm above the neutral axis. So this is 20 mm above the neutral axis. So let me just copy this into my Word. Okay, so now let us try to solve this numerical. Now we have tau is equal to f into a y bar by I into b. You need to calculate all these things. Now let us first note down the given data. Given the cross section is given, so I will write that b is equal to 150 mm, d is equal to 200 mm. This is not required. Shear force is given. F is equal to 6 kilonewton. Then find the shear stress at a distance 20 mm above the neutral axis. So that is your y is equal to 20. Okay. Now we know that shear stress is equal to this, right? F into a y bar by I into b. Now let us calculate all these values. Now a, what is area? Area is area of this shaded region, right? The section above the point or plane where you need to find the shear stress. It is not the entire cross section. So this length is now this length is d by 2. D by 2 minus y is this length, right? So area is equal to d by 2 minus y into b, right? So this will give me the area of this shaded region. So this is equal to d by 2. D is 200. So d by 2 is 100 minus y is 20 mm. 100 minus 20 into b is 150 mm. So 100 minus 20 is 80 into 150 is 12,000. 12,000 mm square. Right? So that is the area. I got this area. Next is y bar. See, y bar is the distance of the center of gravity of this particular shaded region from the neutral axis, right? So if you want, I'll just show you again. You see here, this is the neutral axis, and this dot you can see here, that is the center of gravity of EFGH. So the distance between neutral axis to this center of gravity is taken as y bar. So I have to calculate y bar in this now. So this is a rectangle. The center of gravity is at a distance half of this length, right? So y bar, or I'll put it in an equation. So this is y bar is equal to uh, half of this, right? So it is 1 by 2 times d by 2 minus y. D by 2 minus y. See, this length is d by 2 minus y. We did that earlier, right? So d by 2 minus y, half of that d by 2 minus y is the center of gravity from this edge, plus y will give me the actual location. So it is y plus half d by 2 minus y, that will be y bar, right? So this is equal to y is 20 mm plus 0.5, that is half, d by 2, d is 200, d by 2 is 100 minus y is 20, right? So I can just do it. This is 80, 80, half of 80 is 40, 40 plus 20 is 60. So this is 60 mm, right? So y bar I have calculated. What else is required? Now I need I. Uh, I is equal to BD BD cube by 12, right? So this is I. Now I have all the values, I can just substitute. This is equal to B is 150, correct? And D is 200. So 150 into 200 cube by 12. I is for the entire cross section. So 200 cube into 150 by 12. Okay, this is 3, 6. 100 into 10 raised to 6. So this is equal to 100 into 10 raised to 6 mm raised to 4, right? So that is the moment of inertia. Anything else need to be calculated? B is no. So I just have to substitute in this expression and I will get the shear stress. Therefore, shear system is equal to F. The value of F is 6 kilonewton. So I will put it as 6,000 Newton. Area is 12,000 mm square. 12,000 mm square. Y bar is 60 mm into 60 divided by I into B. I is 100 into 10 raised to 6. 100. Let's copy this. 100 into 10 raised to 6. Put this in a bracket. Into B is 150. So this is equal to, let's just calculate, 6,000 into 12,000 into 60 by 150 by 100 into 6. Yes. Oops.
So it should be divided.
Yeah, I think I made a mistake. See, with this calci, it goes little messy. So 6,000 into 12,000 into 60 by 150 by 100 by 6.288. Is that correct? Where is my calci? This is easier. 6,000 into 12,000 into 60 divided by 100 exponential 6 into 150. Yeah, it's 0.288 megapascal. That is the stress value.